All right, let's run through another chemistry question. This one says, an excess of NaOH is treated with 1.12 liters of HCl gas measured at STP. What weight of sodium chloride is formed? The reaction runs to completion. All right, so the first thing we want to do here is write a balanced equation. So we're going to start with NaOH and HCl. So we've got NaOH and HCl. This is going to be a double replacement reaction. We got a strong acid and a strong base. So we're going to get a salt and water in this instance. The H is going to hop on with the OH and make H2O. And then we're going to have a salt, which is NaCl in this instance. You got to make sure our equation's balanced. So we've got one sodium on the left, one sodium on the right. One oxygen on the left, one oxygen on the right. We got an H here, so that's two hydrogens, and then two hydrogens on the right, and then one Cl. So we're actually totally balanced here. All of our coefficients are ones in this equation. And then we're just going to dive straight into dimensional analysis. So we're trying to figure out the weight of sodium chloride formed, and we're given liters of HCl. So we're starting off with 1.12 liters HCl. We're told that it's at STP. So typically when we want to change from one molecule to another one, we're trying to go from hydrogen chloride to sodium chloride. We're going to need to go into moles and use the mole ratio to convert from one thing to the other one. So I want to figure out how many moles of HCl are in 1.12 liters. And I know that a gas at STP has a volume of 22.4 liters, that's HCl, for every 1 mole of that gas. So I've canceled our liters HCl, and now I'm in moles. Now that I'm in moles of HCl, I can switch to moles of sodium chloride by using the mole ratio. And our mole ratio is just the coefficients in our equation. Our coefficients are just 1. So for every mole of HCl, we're also going to have 1 mole of NaCl. So now I'm in moles of sodium chloride, but I want the weight of sodium chloride. Well, what relates moles to weight? That would be the atomic mass. So we're going to have to do an atomic mass calculation for NaCl. So sodium has an atomic mass of 22.99 grams per mole. Chlorine has an atomic mass of 35.45 grams per mole, which gives us a total atomic mass of 58.44 grams per mole. So for every 1 mole NaCl, we're getting 58.44 grams of NaCl. Now we've arrived at our unit that we were looking for. All the other units are canceling. Moles HCl canceling out. Moles NaCl canceling out. Now we can just multiply the tops, divide by the bottoms. When all is said and done, we get 2.92 grams NaCl.